Today we are going to see on the topic computer system architecture. In that we are going to see what BCD, gray code and ASCII code is and how a decimal number or a binary number could be converted into BCD or a gray code or ASCII code. So let us see one by one. Now we'll see what the abbreviation of BCD is. BCD is nothing but binary coded decimal, so it is another process for converting a decimal number into their binary equivalents. So it is a form of binary encoding where each digit in a decimal number system is represented in the form of bits. This encoding can be done in either a 4-bit code or 8-bit code. Usually, we will have a 4-bit. So the BCD code will be a 4-bit code. So it is a fast and efficient system that converts a decimal number into a binary number as compared to the existing binary number system. So these are generally used in digital displays where it is manipulation of data is quite a task. So thus BCD plays an important role because the manipulation is done treating each digit as a separate single sub-circuit. In the BCD numbering system, the given decimal number is segregated into chunks of 4 bits for each decimal digit within the number. Each decimal digit is converted into its direct binary form, usually represented in 4 bits, as I told you. So let us take a binary number. So the next we will see this table. In this table, you can find the decimal number from 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. So these are the decimal representation. As in a number system, usually we represent from 0 to 9. Okay, so we will convert this 0 into, we can say, BCD code. We can it is otherwise called as weighted code. Okay, so 8421 code or 4221 code or 5421 code. So we will see 8421 code now, how it is being converted. So you have to convert the decimal digit 0 to binary equivalence. So 0 4 bit, when you take it is 0000. So 1, it will be 0001. So 2 will have the binary equivalence as 0010, because see, as we have seen in the earlier videos, how to convert from decimal number to a binary equivalent. So that equivalence, when you do, you will get the value for 2 is 10. The value for 3 is 11. Value for 4 is 100. Value for 5 is 101. Value for 6 is 110, 7 triple 1, 8 1 triple 0, 9 1001. So this is the decimal digit and this is the binary equivalence, and it is called as the 8421 code. Likewise, you have the other decimal digits also. So and it is also called as a weighted code. Okay, so we'll see gray code. So gray code is a non-weighted code, and we say here it is reflected by a binary code or a gray code is an ordinary of the binary numeral system, such as two successive values differ in only one bit, so binary digit. So a gray code is an encoding of a number so that adjacent numbers have a single digit differing by 1. The term gray code is often used to refer to as reflected code, or more specifically still, the binary reflected gray code. The gray code is an encoding of numbers that adjacent numbers have a single digit differing by 1. So the term gray code is often used to refer to as a reflected code, or more specifically still, the binary reflected gray code. So So this is the example for a gray code. Now we have a decimal number, as I told you, 0 to 9 or 0 to 15. So the binary equivalence, how we have to convert it into a binary coded form. Then from binary we have to convert into a gray code. So here the first digit as it is we have to take. Okay, so for example 000. So all the first digit 0 as it is we have to put. Then we have to add 0 plus 0, 0 plus 0 and 0 plus 0, the adjacent digits. We have to add and we have to eliminate the carry bit. So then we'll get the resultant like this. For example, 0001, the first digit will be 0, 0 as it is we write, and we have to add the 0 plus 0, we'll get 0, 0 plus 0, we'll get 0, and the fourth digit is 0 plus 1, so that will be 1. So this is the gray code. For example, here in the binary code is 0010, we have to write the first digit 0 as 0, then 0 plus 0 we'll have a 0, 0 plus 1, that is the third digit, we'll have 1, so here the value becomes 1. In the third gray code, when you see 001, it becomes 1. Then with that we have to again add 1, so 1 plus 0 will become 1. So here the binary code will of a decimal number 2 will be 0010, the gray code will be 0011. So we have to add the adjacent digits, and we have to eliminate the carry, and we have to write the whole number as it is, so that becomes the gray code. So this is then likewise you can do it for the remaining digits, mean decimal number also. So as you all know, the ASCII code. So every value will have an ASCII. For example, special characters. We have decimal numbers. We have binary numbers. We have special characters, etc. So when you want to convert a for every characters, for example, plus or minus or operators or operands, we have a equivalence, ASCII equivalence. So that is a machine understandable language. So this is the equivalence for that. The number will be assigned. So this is an ASCII code and it is an example. So thank you once again.